Welcome everyone to a new webinar on KAPE. Today's session will focus on how to use KAPE and SQLECmd with EventTranscript.db. We'll hear from Kroll's Andrew Rathbun and Josh Mitchell, who together have spearheaded the discovery of the Windows artifact EventTranscript.db and how to parse it with KAPE. Before we switch to Andrew and Josh, a few housekeeping items. Today's session will be recorded and you'll have access to the recording in a few days. We encourage you to submit questions via the GoToWebinar client, which should be floating somewhere on your screen. We'll try to answer as many questions as possible and follow up with answers after the event if we do not get to your question. You'll also find on the client a handout section where you can download relevant material. A brief reminder that KAPE is free for law enforcement, government agencies, for research, academic, or personal use. If you are using KAPE in a paid engagement or on a third-party network, an enterprise license is required. Licenses are available at kroll.com/KAPE. Finally, if you are interested in learning more about KAPE and securing your certification, we have a few upcoming virtual sessions. These are small group sessions with ready access to Kroll experts. With that, I'll pass it to Andrew and Josh to kick off the presentation.
Thank you, Hannah. Hey, everyone, this is Andrew Rathbun. I'm here with Josh Mitchell. Thank you for coming to the webinar. Appreciate it. Know your time is precious, and we'll get right into it. So this is an overview of what we're going to cover today. And we'll just get right into who we are. My name is Andrew Rathbun. Like I said, I'm a senior associate with Kroll Cyber Risk. I'm a KAPE instructor. I have spent time in federal law enforcement, local law enforcement, also prior military. I was in the U.S. Marine Corps as a rifleman. Also the Digital Forensics Discord server administrator, as well as contributed to About DFIR, and I'm a GitHub enthusiast. And my partner here, Josh Mitchell, take it away.
Hello, hi, I'm Josh Mitchell. I am a senior vice president here with Kroll. I focus on software reverse engineering and malware analysis in support of DFIR investigations, expert witness cases, and sometimes I do stuff with proactive team. My background, former U.S. military as well, from Air Force. That's it.
Thanks, Josh. All right. So EventTranscript.db, that's why we're here today. This is a SQLECmd database that I stumbled upon earlier this year when I was doing research trying to build out maps for SQLECmd, which is a tool we'll cover later in this presentation. But it's existed around since Windows 10 version 1709 and exists today on the most current build of Windows 11. I think that's technically not the most current build, but at the time of this presentation, that's the most current build, the KB 56050. EventTranscript.db relates to telemetry and diagnostic tracking. It's basically the back end for the diagnostic data viewer, which is an application that you can download from the Microsoft Store. It has multiple levels of diagnostic tracking, which we'll briefly touch upon. And there's a lot of documentation on Microsoft's website in regards to diagnostic data and telemetry, but nothing really talks about EventTranscript.db as the artifact itself. And there's no documentation about this DB in any sort of forensic light prior to this. So, and DiagTrack.dll, which Josh will get into a little bit further, controls the recording of diagnostic data events as they relate to EventTranscript.db. And with that, before we get into Josh's part, here is what the SQLite database looks like for EventTranscript.db. You'll see this slide a little bit later, but this is just a nice pretty picture of how many tables there are and what's in it. So Josh, we'll hand it over to you.
Sounds good. Go ahead. So as Andrew mentioned, he came to me with this awesome forensic artifact, right? Like, sounds amazing. So we really needed to understand how the data was being put into that database, what kind of controls happened, like what really made this thing work. So to that end, I've started pulling apart the kind of massive project that is Windows telemetry subsystem. Now, I apologize for the simplicity of the graphic, but this is kind of our understanding right now about how things work, right? So you have the DiagTrack service. Now that connects to Microsoft through various REST API endpoints and pulls down data collection packages. Those data collection packages are used to dictate the behavior of process collection nodes, which are userland processes that you and I use, as well as dictate the behavior of the compatibility layer. Now, these things, if you will, are stored in the registry, and there's lots of communication between these various components and the registry at the varying levels where this stuff happens. And we'll get into that here now. Go ahead. The DiagTrack service maintains most of its registry settings under the software Microsoft Windows current version diagnostics key. Now, under that key, we can see here on the big folder view, right? If you go down to the bottom, you look for the word tenants. Underneath that, you have P area. These are the enabled data collection packages that are running on your box right now. Now, if you go further up from that, you see the key settings request. Now, these are all of the ones, at least what we believe, are all of the ones that are currently installed on your box, right? So not all of the telemetry packages are there, and the ones that are there, not all of them are enabled. Now, the things that dictate the behavior of these telemetry collection packages, we believe, are stored in JSON and XML documents that are downloaded from the Microsoft REST API endpoints. These are typically stored in JSON files in the last file written path, as you see there down at the bottom. Now, pulling apart some of these JSON files, we can see the collection names down in the far right. Those are the different event names and the collection rates, and how much data to get. And the interesting thing is that whether or not the packages are enabled, this seems to indicate that the data is always being given, right? It's just whether or not the JSON package is there to tell the system to record it, which is pretty neat. So next. So now we're going to talk about some of the control mechanisms that impact logging. Like as I said, some of these things are enabled, some are not, but the data is there. So how do we figure out if the data gets sent to the database and then as a result sent back to Microsoft? Now, inside of the DiagTrack service, there is a DLL that is used called flight Settings.dll. And that DLL wraps calls into policy manager.dll, and we can see on the right-hand side some of the different registry values that are checked by policy manager.dll, and then back into flight settings.dll, right? So these types of registry keys we can see here definitely seem to indicate that this is how we decide if we should enable or collect the telemetry packages. Interestingly enough, these values right here from Policy Manager are actually also checked inside of Microsoft Edge through the Windows System Profile Platform you can see. Now that DLL seems to provide the same type of functionality as flight settings, but in a user-controlled process in Edge. And one of the big values that we've come across is this allow telemetry value. Now that seems to show how much data is collected, right? Whether it's verbose or whether it's just minimal collection. That this key seems to control how verbose it is. Next. So as we had said, that there's this flight settings.dll that also wraps around policy manager that seems to show how the behavior is managed. Also within flight settings DLL is a pretty neat thing that we came across, and these are these down here at the bottom. You see you have like FX:11900330E, right? These seem to be related to different flights is the terminology that's used when we look into the JSON and we look into the diagnostic data viewer. We can see a direct correlation between these flight ID numbers and the various collection packages that are being run on the system. You know, obviously going by the name, it seems like it's related to experimentation. We don't know yet, but it is just another example of the different kinds of things that we have left to figure out, right? There's quite a lot. Go ahead. As I mentioned, there's quite a lot of things involved. On the right-hand side, you can see approximately 25 different executable binaries that we have identified thus far as being related in some fashion to the telemetry subsystem. So yeah, we've just begun to scratch the surface. Like how messaging works, we really haven't even gotten that far. There is a lot of event tracing for Windows going on. There's a lot of CRM and RPC messaging taking place. There's scheduled tasks, scheduled services. There's a lot of stuff. And there's a lot of unanswered questions, like how is one core involved? Because in all of these binaries, or in most all of these binaries, there's references to one core, which is the new Microsoft Unified Kernel, which is kind of interesting. If you look at the compat tel runner executable, that is for Windows compatibility, at least that's what it says it's for. And that's a service, or that's a scheduled task that gets run from DiagTrack.dll, but it has a hard-coded list of various other DLLs that it runs in conjunction with it. For example, generate tel.dll or general tel.dll, which searches your computer for running processes whose names match common, really popular games. Right, so unless this is in some way trying to unify Xbox telemetry and Windows desktop telemetry, really you know, why else would it be doing that? Why would it be looking for a hard-coded list of games running on my computer? Why? I have no idea. But that's kind of the idea, and we're just kind of getting started in unpacking this whole thing. So, go ahead.
All right, so thanks Josh for that, appreciate it. Long story short with this artifact, it is absolutely massive. It can be massive, it also can be, like you said, different levels of verbosity. It can be not that big, it can be really, really big. And there's a lot of things that we're still trying to understand that impact this artifact. But what we do know now is that we can parse what we've seen, and this is how we do that. And we use SQLECmd, which is a tool by Eric Zimmerman to parse SQLite databases. Really regardless of where they came from. Obviously KAPE is used on Windows systems, but you can use it to technically point at a folder of, you know, SQLite DBs that you extract from a phone, for instance, or from Linux. Anything that has a SQLite database, you can parse it so long as there's a map for it. And that's an example of a map here. It very similar to targets, modules, maps, batch files, all that. The main thing is the SQL query here is what's going to be ran against the data. So, yep, as I said, SQLECmd utilizes maps just like EventTranscriptDB. If you see my previous webinar on that, it's very same concept. It's just we're parsing SQLite databases instead of event logs here. And so there's parameters that these maps have to have in order, so SQLECmd can match the DB with a map. So for instance, right here, the identify query and identify value are what we're referring to here, and we will get a little bit more into that later. And anyone can create a map for any DB in existence, as long as it's a SQLite database. So when you're using SQLECmd, and mind you, this is an example where you're just using it on its own. It's just like any one of Eric's tools. You're calling the executable, -D for directory, D or F, directory or file, the path to the DB or the folder, output to CSV, and then where you want the output to be. And I always run debug. I would suggest you always run debug, because when you have an issue, hey, I'm having an issue with this, well, you're either going to be asked, okay, go run it again with debug, or if you already have debug ran, then you have what you need to provide for troubleshooting. So here's a refresher of the EventTranscript.db schema, and I'll probably pop back to this here in a second. But this right here, here's the map for EventTranscript.db that we're going to talk about right now. So I talked about the identify query and the identify value in that map. So this is copy pasted from that map, and I just want you to understand what this is doing, because not only will it help you understand what it's doing for this database, it'll also help you understand what SQLECmd is doing in general. So SQLECmd is going to look, it's saying, it's basically enumerating what tables are in a database to make a match with the map, so it can run the map, aka the query, against that database and provide the output. So this is saying I'm looking for a DB that has categories, event tags, events persisted, producers, blah, blah, blah. We see that right here. This is EventTranscript.db opened up in Navicat. So it's saying these have to exist, but then the value is 4. I want 4 of those to exist. So long as 4 of these are a hit, that means it's going to run that map against that database, and it's going to provide the output based on what the query is, which I wrote the query for this one, so it's going to be what I deem to be most appropriate for the output for this. I say that because you may not agree with my query. You can always modify it. You can, do a pull request. You can make your own. Just keep it on the side. That's the whole beauty of open source here. So the reason why I do 4 is because I have sometimes seen where there's only 4 of these tables, and that I think that depends on the different level of data sampling, which we didn't really get into a lot, and is frankly something that we don't quite fully understand. But basically, if there's no data sampling, then you'll probably only see 4 of these. If there is data sampling enabled, then you'll see probably all 7 of these. At least that's what it's been so far in our research. So here on the bottom, so long as the identify query, identify value are valid and the DB file name matches. So we go back here, right? File name, it's looking for this file name. It's looking for these tables, and it's looking for 4 of them to match. Then we're going to get parsed output for the map for EventTranscript.db, and really any other DB that you parse with this tool. So for the map in particular for EventTranscript.db, it's going to output 6 different CSVs. And so on my system, my EventTranscript.db was a gigabyte in size. It's massive. So if I wasn't breaking it up, I'm going to have a gig CSV to look at. And while Timeline Explorer can handle that very easily, it's just better just to split up the data for obvious reasons. So I decided to do that by tag description. So all the different events that are in EventTranscript.db, they fall into one of these 6 categories, which you can see here, okay? And so on this example here on the bottom, you can see there's only 5. That's because on my system, for whatever reason, I just didn't have any data that fit inking, typing, and speech utterance. So, but this is what your output's going to look like. You can see the size of the different output here. It's a little more manageable than, one single gigabyte CSV or whatever that totals up to. So, like I said, this helps reduce the size of it. And I attempted to label whether or not there's data sampling or not. So, like I said, if the identify value is 4, then that means it's likely no data sampling. If it's 7, that means data sampling. And you can see that right here. This would be your timestamp, Windows, EventTranscript.db, tag description, and then _ data sampling. So that means it got a hit on the data sampling map for SQLECmd. And so using Timeline Explorer, this is just a screenshot. Sorry, no GIF on this one. I thought about it, but there's just way too much to show. The main thing I wanted to talk about here is this full event name. This is what you're going to want to toy around with. Whenever you do find this DB and you parse it and you're trying to figure out, okay, how do I make sense of this? What is this? It's a lot of stuff. I just don't know what to make of it because it's totally new. Toy around with this. Filter on certain ones that look interesting, right? Download completed. There's going to be a column over here to the right called payload or JSON payload. I forget exactly what I have it as, but each one of these events is going to have a unique payload, just like how every event log, like a 4624 has its own certain things it logs compared to a 4625, compared to a 4778, compared to you name it, every single one is unique. Exact same thing here. And this is, instead of, security 4624, it's this kind of naming convention, Microsoft.windows.featureexperiment.aggregated staging state. So really the task for research right now is to figure out which one of these are going to provide the most quick wins. And we have uncovered a few, and others have uncovered a few. We're sure there's many more because we've already seen about 2,500 of these things. So moving right along, just some tips and tricks from using SQLECmd. As always, I always harp on this. Make sure you're always running a sync, keeping your maps up to date. If you're ever having any parsing issues, you're not getting output, the answer is always going to be delete your maps folder, run a sync again, because you're likely having some conflicts. Going down here to the hunt switch, that's something I want to make sure people know about. You can use this tool to run hunt. And so if you point to, say, your C drive and you just run it with the hunt switch on, it's going to traverse recursively the entire C drive and look for files that are SQLite databases. That's awesome because sometimes they're .db, .db3, .SQLite, .SQLite3, and sometimes they don't have any file extensions at all. So it's really helpful where the tool will look for those, I believe, file headers, and it will tell you, yep, this is a DB, this is not a DB. So that's a really good way to find out new artifacts. Hint, hint, people looking to write and blog about something, go do that. So as I said, Navicat for SQLite's a tool that I use. Oh yeah, there's no right or wrong way to locate these DBs, but the hunt switch makes it very, very easy. And again, as always, if you need help building queries or finding databases, just contact me on the various ways to get a hold of me. Discord, Twitter, LinkedIn, usually the best ones, and let's solve the world's problems together. So let's get to KAPE now, how we can automate this. So for those who don't know what KAPE is, I'm sure most of you know what KAPE is, but we'll just do a high-level overview. It's primarily a triage program, and it uses targets and modules to basically do things. Targets are going to be, hey, I want to grab things that exist in this location. Modules are saying, hey, I want to parse that stuff that was in that location and make sense of it. CSV output, JSON output, HTML output, whatever the tool allows for. So KAPE can be used to collect the most critical artifacts prior to the start of imaging. So a lot of times when I run my KAPE triage EZParser workflow, usually it takes about 400 seconds, as long as there's not something anomalous like massive, event logs or something else like that. So going right into that KAPE triage and EZParser workflow, here's a couple mind maps I made. Obviously not going to spend a lot of time on this right now, but these are on my GitHub if you ever do want to look at these. But this is just an overview of what KAPE triage pulls. It helps you understand what compound targets are. So these are all going to be your compound targets that are just pointing to different targets. So in the interest of time, here is EZParser, and same thing, it's a compound module. It's running all the modules for all these individual tools here. And it's doing these things here. And then I tried to output, okay, CSV is a possibility, CSV JSON is a possibility with this one, CSV JSON, CSV HTML JSON, you get the point. So now automating it, whenever you're using KAPE, the most common workflow, like I said, is EZParser, at least for me. KAPE triage, EZParser, I've made it to where KAPE triage is almost a one-for-one with EZParser. So long as that artifact exists, a tool, an EZParser module will be put to work. So there's no one, no one slacking. None of those tools don't have anything to do, basically. So if you look at the EZParser module and you see what tools are there, the KAPE triage target is going to put each one of those to work. And so this is just a snippet from that EZParser module mind map that I made. And any output from SQLECmd is going to show up in your SQL databases folder, which is wherever you specify your module destination. So again, the EZParser module with this SQLECmd module, this is a snippet of EZParser right here. You can see it's just pointing to the SQLECmd.mcape, the module. And this right here is the module itself. So you can see what it's running. It's running that executable -d, source directory, -csv, where do I want my output to go? All right. And this is just a GIF because I couldn't do a webinar without having a GIF, right? So this is a GIF of just my everyday workflow of, set my target source destination, module destination, KAPE triage, EZParser, CSV, output, debug messages. This is going to get you most of the answers that you need on IR engagement, in my opinion, at least. So we're acquiring targets, or we're acquiring files, artifacts with the KAPE triage target. We're parsing it with the EZParser module, so we're leveraging almost all of Eric's command line tools. We're setting it to CSV for the format. Debug messages helps us for troubleshooting, and in case you need to go, man, did they find that file, or how come I'm not seeing what I expect? Well, debug messages are going to help you with that. And any of this output can be put into Timeline Explorer, Modern CSV, Excel, depending on the size of the CSV, or really any other CSV viewer tool for analysis. So our final thoughts on this, again, this could be like a 2-hour presentation, but there's just so much that we got to confirm. There's so much we still want to know. But we speculate that diagnostic data and telemetry in Windows is here to stay. It's reasonable to speculate that the level of logging should only increase over time given the value of the data. I know that's a big thing with software development nowadays is, they want to know what users are clicking on which buttons so they know how to best improve the user interface. And I understand that, I get that. So I think it's here to stay. I think it is only going to go up from here because of the benefit that it provides for software development. And if that's the case, I mean, this should be more prevalent, more useful over time, especially as more research is done on it. And I highly recommend you check out the Kroll blog series that we got going on this artifact for some of the quick wins that we found so far. But regardless, if this database exists without data sampling, it can still serve as a redundant source of information for some stuff that you can find in the registry or event logs. And a lot of times what we found is, yeah, there's redundant data, but also there's some extra stuff. Like, for example, sometimes you'll see the resolution of the display at the time of the event. That's not something that you're going to see in an event log. So some of that contextual stuff might help maybe more in the law enforcement realm than IR. But again, a lot more research needs to be done. The most important thing about this, especially for law enforcement and IR, is that this persists conventional anti-forensic methods such as event log clearing and time stomping. We've tested it, we've cleared event logs, and this database still persists, nothing changes. So again, it's a redundant source. It's another source to find, the SHA-1 of a particular executed file, just like Amcache, for instance. And like I said, we've found over 2,500 events, so it's going to take a while to figure out which ones are useful or not. I do have a full list of all the ones that I found so far on my GitHub, but I strongly recommend you explore it yourself, report your findings, blog about it. I can almost guarantee whatever you find is you're probably going to be the first person to find that at this point. So pivot on the event names like I talked about, try to find those quick wins for us, share your findings. And anything, if you ever want to discuss anything, you want to share your findings, go ahead and do it on the EventTranscript.db research GitHub repo. I believe I have a link to that later on here. But first, is there any questions? I actually do see a question here from Chris. So KAPE triage does not collect EventTranscript.db by default. EZParser will parse that DB if it is present, because EZParser is going to be running the SQLECmd module. So if you're running the SQLECmd module, technically any database that has a map written for it is subject to being parsed, so long as it actually does exist where you're running that module. Does that answer your question? And actually, to answer that a little bit further, there is an EventTranscript.db Target. If you would want to add that in addition to the KAPE triage target. So hopefully that adequately answers that question. Awesome. See another question. If the security event log rolls over in a day on a computer, how much persists in the database? So I would recommend you go look at the blog series on the Kroll website, because we go into the settings that the user can set for how big they want the DB to be, how many days they want it to record. I mean, it could be anywhere from, I believe it's like 1 day all the way to 180 days. That's just going from memory. So it depends. That's kind of separate of the event log. If you set a certain limit on the security event log, for instance, that has no bearing on the EventTranscript.db diagnostic data viewer backend, however you want to say it. It's a completely separate set of settings in the registry. And does that answer your question, Gary? Awesome. You're welcome. Any other questions? Hannah, do you want to handle some of the more common questions that we're seeing, the repeated ones? You should be getting a copy of the presentation here in a couple days. So I would just stay tuned to your email. But here's some resources that I put together. That top one, that's something that you can Google for, the Forensically Unpacking EventTranscript.db investigative series on the Kroll blog. I have a couple GitHub repos that are relevant to this particular webinar. That's the KAPE files repo, which is where all the targets and modules are. And then the SQLECmd one, that is where all the maps are going to be. And then here's a couple GitHub repos of mine. The EventTranscript.db research repo, that's just kind of where we're centralizing some of the ongoing research. Again, there's a discussion board there if you ever wanted to ask questions about it or anything like that. And then the awesome KAPE one that I put together in the last couple weeks, it's just in line with all the other awesome repos, it's just and there will be a link to this webinar at that awesome KAPE repo. It'll be every single resource that exists for KAPE that I know about, it's right there. So you only got a one-stop shop, and it'll give you a link to everything that you need, every YouTube video, every blog post. And if I'm missing one, let me know and I'll add it.
Super awesome. Do it.
All right. All right. Hey, Hannah.